All right, here we go. When I can get it to come back on. Guys, shh, please. My goodness. It's just a new function. Same thing. It's coming.
Is it going to be the same amount of questions on this test?
What?
Is it the same amount of questions on this test?
Absolutely. All right. So here's your new function. Let's see if I can make it any.
Are you going to share this copy of what you're doing here, like on the problem?
I can email it to you probably.
Okay, so I'm just going to put the one.
I would go ahead and write the function. I would not write the chart because you know how to do the chart. You know what I'm saying?
Are they just going to give us random numbers? Is the chart based on?
Where's our limit going? Read the question.
Oh, I see it.
As it approaches 7, so it's going to give you the value set.
Is it always going to give us some value?
Yeah. Yeah. Now, there's only like 2 that you have to fill in the chart for. That's it. So just make sure that you can put it into your calculator. So everybody is good with putting it in their calculator, right? I'm gonna go ahead and put this one in so you guys can see it. I'll have to switch back and forth, so this is probably gonna be a hot mess. Bless you. Minus. So 6.9. Guys, why are we talking so much today? Shh. You're good. I know what you're doing. So I'm hoping that I have it sharing right so that it's recording this screen. So as it goes to 7, and a lot of times, guys, what I'll do is go ahead and put the 7 in there so that I can see it from both sides. It's up to you. The chart doesn't have it, but I usually put it in there just so I can see where those numbers are going. So they're going to negative 0.062. Did you get fractions? Did you guys get fractions?
Yeah.
Okay, so here's what I did to not get fractions. I put 0.25 instead of putting 1/4. So that helps me not get fractions. So maybe that's something you can do tomorrow. All right, it's up to you. Or you can change them, or you can just put the fractions. As long as you know what it is, it's not going to matter. So what was the value that we had? Guys, what was the value? Positive or negative? Negative. So make sure that you know that. So if you look at your multiple choice answers, which one is it? A. That's it. So put it in your chart and pick your choices.
What did you just do? Yeah.
What was your values next to 7? Negative 0.062, right?
Yeah. How do I know not to use the 0.06?
Well, look at your values.
Oh, 'cause it's not all-
There's only one. There's only one value that matches
So
it.
it's going to be the one that below or above there. Like on the calculator it says error.
Oh, the 7. Yes.
Yeah,
Yes. Yep.
The one below.
Yep. And that's why I put the 7 in there so it doesn't confuse me. Like this is where I'm looking. Does that make sense? Okay. Next one.
Wait, so how do you know how above and below is?
I'm not understanding what y'all are asking me or why it's confusing. I need you to explain to me what you're confused about rather than asking me. I don't
It's
know.
like the 7, you're going to 7 error. It's just whatever's below or above it, right?
I got you. Yes.
Okay.
Yes.
And it's just, it happens to be
Yeah.
that.
And
that
because
one
these
is the
are,
next choice.
remember, because these two go to the same number, this limit exists. You got to watch because if it's opposite numbers or something like that, it doesn't exist unless we choose it from the left or the right. Does that help?
So if negative 0.63 was the answer choice and that one wasn't, I can pick that.
Yes.
Okay. Yeah.
But it is the answer
Yeah.
choice. Is everybody good? Just watch your positives, negatives. That's what I was pointing out on that. Is everybody okay? Did I answer your question? What is your question?
Like, I just don't know, like, when I choose one that, or like, some
They're both the same. If it had more decimals, that 0.062 would round to 0.063. So it's the same thing. They won't have anything close to like, they won't do that. Does that make sense? Is everybody good? All right, I got you now. Sorry, I'm not trying to be like, I just want to make sure I'm answering the correct
I'm just trying to
questions.
make sure that don't hit simulate thought.
Like you literally can't, I mean, like you can't miss this question. And you saw the first one looks exactly like it. Yeah, I just hit regenerate. Okay. All right, let's look at number 2.
There's not gonna be any more corridors for this.
I mean, they're okay. They're okay. Let me drop this one so you can see the whole thing real fast. All right, so on this one, I don't know if I can make it like a little bit bigger. All right, so number 2 says let f of x equal 4 minus x when x doesn't equal 1. I also learned how to put these in the calculator. Thank you, Miss Tierney taught me. So I will show you how to put these in the calculator when you have to do it yourself. Okay, this one's already graphed for you, so I'm not even going to worry about it on this one. And it said the limit as it approaches 1. Well, what happens at 1? We just need to look at the graph. We don't even care about the functions right now. Just look at the graph. There's a hole. What else is there? When you have that 1 dot, ignore it. Okay, so I don't know if you need to write that down or whatever. You need to kind of sketch this out. Whatever, you ignore that. So we're looking as it approaches 1 from the right and the left, it comes to the same point. What is that point right there that is approaching? That's your answer. That's your answer. So ignore that dot. Ignore that dot. Because it comes to the same. Remember, that's that removable discontinuity that we have. Okay, so just ignore that point on there. So anytime you have a point like that, you want to ignore it. Okay.
So what do you mean that it comes together? Like the two?
Your graph from the left and the right. So from the left and the right comes to the same point. So the limit does exist because it comes to the same point.
Because it's not asking for like the right or left.
Right.
Okay.
Correct. Everybody understand that? All right. So this one, this next one, it graphed it for you. It wants the limit as x approaches 2. It doesn't specify right or left. What happens is we get to 2. It does not exist. Why does it not exist? Yeah, they don't go to the same spot. So on this one, we're going to have it does not exist. All right, look at number 4. Good gracious. Find the limit of x plus 2. I'm going to make this bigger, but it's going to mess it up. So just give me a minute. All right. What do we do on one like this? You don't have to graph it.
Oh.
Yeah, you just use direct substitution. And the reason you use direct substitution is because x plus 2 is a continuous line, right? It's just a straight line. There's no holes, no asymptotes, nothing crazy about it. So this one's just direct. So plug your 7 in. 7 plus 2 is 9. That's it. So this one is direct. You might want to write this. Again, I would write them down. I will email you.
Pardon the interruption. Could the
Sorry.
school nurse, Ms. Kelly, please call the office? School nurse Kelly, please call the office.
All right. Number 5. What about this one? Okay. The question is, can we? Can we do direct substitution? When we plug it in, what do we get? 6 over 6 squared is 36 plus 8 is. So we had 6 over 44. Did we get 0 over 0? We can use direct. We can use direct. Okay, so you said 6 over 44, 3 over 22. We reduced that. So right good. So this again is direct. And again, why is it direct? It doesn't give me that indeterminate form. Remember that. It doesn't give me the indeterminate form.
So if it does, can you just plug it in?
If it gives you which one?
Like if you have the 0 on the bottom.
You're probably going to have to factor. You're probably going to have to factor. All right, so let's look at number 6. Number 6. And I'm going to pull out some paper so that I can show you guys if we have to do work. All right, so on number 6, and I'll move it so you guys can see it. We have f of x equals 4x minus 2, g of x equals x to the third. Find the limit as x approaches 1 of g of f of x. This problem is not hard, okay? It's not hard. You got to know what to do. I always write whatever they put first. I'm going to write g of x first, and then f of x. And it says put that in there. Okay, so this is one you might need to think about. All right, so instead of x cubed, we're going to have 4x minus 2 cubed. You should know that a cubic function looks like this, or if it's decreasing, it looks like that. It's continuous. That's the big thing, is that it's continuous. Not going to give us an indeterminate form. So this is a straight direct substitution. So we're going to do 1. So 4 times 1 minus 2 cubed. What's 4 times 1? 4 times 1?
Oh, 4.
Minus 2. 4 minus 2 is 2. Cubed is 8. That's your answer. No, you're not. No, you're not. What does our cosine graph look like? What does our cosine graph look like? Is it continuous?
Yeah.
Sure is. Sure is. So you said it was a wave, right? Which one is not continuous? Tangent, because it has all those vertical asymptotes. We're going to talk about one of those in a minute. All right. So when I put this in, I can do direct substitution as long as it doesn't give me the indeterminate form, and it does not. So we're going to do cosine pi x. I'm going to do alpha y equals pi. Our x is 2. And you can leave it just like that. It doesn't have to be in order. And then 3. There's your question. Sorry, I probably did not. I probably quickly showed it when we were looking at the other one. Is everybody good? All right, so again, cosine is continuous, so it should just be straight direct substitution. When I plug it into my calculator, I get negative 0.5 or negative 1/2. And I'll flip it back to the test so you guys can see that. Yeah, as long as you don't get an indeterminate form, you are good to do it. You won't be able to do it. It'll be an error. But remember, cosine and sine are continuous. The only way you don't make them continuous is like you put something else with it. It's really weird. Everybody good? All right, so let me jump back. There's your question 6. There's 7. So which one would have been my answer? B. Is everybody good with this one? Sorry, y'all tell me when you write it down. We got plenty of time. This is not going to take long. Is everybody good? All right, number 8. Is the sine function continuous?
Yeah.
Yes. So what can we do? Direct substitution. So in your calculator, sine, it's 3 pi over 4. And I'll show you my calculator in just a second. It gives us 0.707, and all of my stuff is in like fractions. So when I look at it, I got a positive 0.707. So that's definitely going to eliminate B and C. It's going to eliminate E because I know it does exist. So then you can just put in your calculator the other one, square root of 3 over 2. So if I type that into my calculator, square root of 3 over 2, I get 0.866. 0.866. If I type in square root of 2 over 2, I get 0.707. So which one's my answer? D. Square root of 2 over 2. And again, a lot of that is using the unit circle. So just so y'all know. If you miss 9 or 10, oh, come on. So it says find the limit. If the limit of f(x) is negative 11 and g of x is negative 3, subtract them. What's negative 11 minus negative 3? Negative 11 minus negative 3. Minus negative is a plus. That's the mistakes that y'all are going to make, not the work, not the actual calculus part of it.
Oh, right now.
Correct. Correct. Everybody good with that? So B would have been your answer on that one. This one is the same way, number 10. F of x times g of x. So what are we going to do? When we multiply it together, what do we get? Positive 150, your answer. Any questions? Number 10. Everybody good? What? This part is 29 questions, but they're not, I mean, they're going like this. Y'all understand? And your test looks through that. So. All right, number 11, 3 times f of x. What's your limit? Negative 15. 3 times negative 5 is negative 15. All right. We're going to jump down to number 12. What do you notice about this one? What happens if I plug in negative 8? I have that 0, right? So that tells me right there I can't do direct without doing something else. Okay. So if you need to write down this function, I'm going to write it down in just a second. Again, I hope you are able to see on my recording this stuff right here. So we have x plus 8 over x squared minus 64. How do I factor that bottom? What happened? So that one is that removable continuity we were talking about, discontinuity. Okay, so that's a removable. It doesn't matter that it's there. We just need to factor it out. Now what happens when I do direct? Remember we were going to negative 8. What do we get? That's your answer. There's a couple you'll have to graph because they're trig functions, but most of them are perfectly good. I try to tell you. If I would have done the review last night and had a bunch of put like, oh my God, they're gonna question this, I would have not done this for your test tomorrow. But and it may only be these 29 questions. I don't know. But if it, like I said, if it's any calculator inactive or any for your stocks, the ones that I've picked out are easy, super easy. All right, is everybody good there? All right, 13. 13. Again, if I plug in that 0, that 2 times 0 to the 8, it's going to give you 0. So what do I do? What I did was I graphed it. So I want you to put it in into y equals. So y equals, and I'll show you my graph in just a minute. Sine x. I'm gonna show you. I just want you to graph it just for a second. I'm going to show you my y equals as well so that you guys can see how I put that in. So sine x parentheses 1 minus cosine x, make sure you close both parentheses, and then 2 times x to the 8. Is everybody good with that? You have to do it this way. All right, here's your graph. Here's your graph. What happens at 0? Why does it not exist? Opposite direction.
If it was asked to the left and right, would you say like negative?
Okay, so if you ask from the left, what would it be?
Negative.
And from the right? Yeah, so it does change it.
Or do we have to go?
Yes, yeah. Is everybody good? Here you go. Here's what it should look like.
Okay.
Do you really? Okay, promise? Okay. Y'all, seriously, if you have a question about how to put it in, just please let me know. All right, going back. All right, so the ones you love. I'm gonna write it down. You guys go ahead and write it down. This one is it actually is easy. It's a pretty easy one. The ones that you have to worry about are when they like square it and stuff. That's when it's crazy. So this is linear, this 4x minus 3. So it's actually a pretty simple one and not as confusing as the other ones have been because you don't have to square it or cube it or do anything crazy with it. All right, so right now I can't do direct substitution because it would give me a 0 in the denominator, so I need to fix it. You guys got it copied? All right, so it says x plus delta x right here. So you're going to change that x to x plus delta x. So 4x plus delta x minus 3. This next part is the part that you'll screw up. You keep doing it. We have a minus. Please put parentheses. Your function, 4x minus 3. That is important because otherwise that 3 will not cancel out of the end. Okay. On the bottom, we just have delta x. So we're going to distribute our 4. Remember, I told you you can change delta x to y if you don't like looking at that triangle, whatever, that's fine. So 4x plus 4 delta x minus 3. This is why it's important to put the parentheses. You have to distribute that to negative 4x plus 3 all over delta x. Because what happens on the top? Your 4x's cancel out. You're left with 4 delta x over delta x. What happens? You're left with? That's your answer. That's it.
So why did we choose
This?
Yeah.
That just says plug this into your function right here. That's what we did right here. So replace x with x plus delta x. This says subtract just your function and then over delta x. Everybody good? Okay. This one I could see you messing up just by just the subtract part. So just be careful about that. Make sure you distribute. All right. Your next one, use the graph as shown to determine the following limits and discuss the continuity of the function at x equals negative 4. So this one, it starts to do right, left, and just -4. So the very first one is right. It's a little plus. I don't know if you can see it. The second one is left, and then there's a -4. What did I tell you about that point? Ignore it, right? All right, so from, I can't draw it. From the left, ignore that point at the top. From the left, where does our limit go when it gets to -4? 2. From the right. So if they both go to 2, then what's your limit as it approaches -4? 2. So these should be 2, 2, and 2. Does everybody understand that? So let's look at what we have down here. We have 2 of those, one that's not continuous and one that is continuous. Which one is this one? Why is it not continuous? There's a hole, so I have to pick up my pencil, right? How do I graph that other point if I don't pick up my pencil? So the only way that this, I keep trying to reach down here, this little point bothers you is in your continuity. All right, so in your limit, it should be all 2, but it should be not continuous because I would have to pick up my pencil to make that dot. It would be like a straight V with no hole.
There would be no, like that open hole makes it not.
Correct.
If a hole makes it.
Yeah. Everybody good? All right, look at your next one. Write this function down. It's 11 to the right. As x approaches 11 from the right. If I plug in 11, I'm going to get that indeterminate form. So I see that 0 over 0. So what do I need to do? I need to factor. So I'm going to drop to mine. I'm going to write this function down. So if you didn't get it right then, you will. It was 11 minus x over x squared minus 121. How do I factor the bottom? Okay, well, what about the top? Yep, how do I flip it around? -1. Just throwing out that negative, we'll flip the x in the -11. All right, so then this will come out. We're left with -1 over x plus 11. This now becomes like that V shape that we just had. It's going to be just that open circle or whatever. So what can I do now? Yeah, you can just do direct substitution. And remember, it was as x approaches 11 from the right. So -1 over 11 plus 11, or -1 over 22. All right, so I'm about to teach you something on number 17. You need to make sure you have your calculator. You need to make sure your calculator does alpha y equals. If it does not do alpha y equals, then you need to go get one of mine. All right, so 17 looks like this. I'm gonna give you a minute to write it down. And then I'll show you how to put these in. That is 1 from the left. Everybody got it right down? All right. You're going to do alpha y equals. On the top, you're gonna put your function, so x to the third plus 10. And on the bottom, you're gonna put your bound, and I'm gonna show you exactly how to do that. So go ahead and type in your x. It says x is less than 1. Everybody got the x? So here's where you go. You go to second math, and it'll list all your little things. So we want to do less than. Second math. Enter 1. Everybody good? You're going to do the same thing in y2, alpha y equals. Your function is x plus 10. And the bottom, we're going to do x is greater than or equal to 1. X, second math, greater than or equal to 1. Everybody good? When we graph it, and I did Zoom 6, just in case yours looks weird. I don't really see much. I'm going to zoom a little bit different. I'm going to change my window to, let's do our max, x max at 15. I mean, our y max at 15. Because I saw the top of it, but I wasn't sure where it went after that. There we go. Did I see it? All right. So what happens at 1? Does it matter? Does it matter if there's a hole? No, because both sides go to it, right? It's not like it's a gap. Does everybody understand that? Holes are different than like jumps. So where does it go to though? Here's your, hold on, it might help to see this. 0, 10, 11, or 30. What's your y value? 11. Is that good? What part? Let's see. 1.01. Look at your y2 value. Oh, sorry, you can't see it. Just kidding. Look at your y2 value. At 1, we had an error, but then we had 11. At 1.01, we have an error, but we have 11. Why are we getting 11? Because we're on the left side. If we did 0.999, see how we get 10.997? Where's that going to? 11. So worst case, do your little chart. Where are we going to? 1. So we put numbers that are less and numbers that are greater than 1. So if you look back at your beginning chart, and you can do this on your test as well, it was 6.9, 0.99, 0.999. So use those numbers.
I just make the graph on.
Oh, go to your window. And I just changed my Y max to 15. That's it. You can zoom out, but you won't be able to see like 111, if that makes sense. Okay. Which one are you putting it in? Okay. So it's a good question. Here's why. Here's why you can't direct substitute. Where are we going? 1 from the left. Which one of these is the left? It's not equal to 1. So I can't direct substitute. Does it still work? Yes. Will it always work? No. Does everybody understand that? Okay. All right. So D on number 17. All right, this one. Its greatest integer function. Don't make these harder than what they are. I'm going to show you how to put those in your calculator. We've already talked about it once. So I know you can't see mine. I'm going to go ahead and type in the first part, 2x, and then this is supposed to be the greatest integer. All right, so when you're doing this, 2x minus, you go to math and over to num and number 5. Math and num, number 5. We're going to graph. Remember, it's a step function, so it's going to look weird anyway. What is your value at 5? Again, because we're approaching from the right, this can be direct substitution. If we're approaching from the left, it would be different. Okay, it's still going to be the same, but it would be different. All right, any questions? Should put it in just like that. Did you zoom? I didn't zoom 6. Did you zoom 6? Should look like this.
My wife is
You did second trace value. Second trace, enter 5. Your Y value. Everybody good?
I missed that one.
All right. Find the X values at any that are not continuous. So what are not continuous values? What are we looking for? And I'll show you what this function is. Let me go to different sheet. This is the next one. I didn't show you yet, but it's not hard. So this is your function, f of x equals the absolute value of x minus 3 over x minus 3. And it wants to know the value where it is not continuous. What are the two things that make it not continuous? A whole or a vertical asymptote. Can I get either one of these on here? Not a whole. I can get a vertical asymptote. I can't factor this. So remember, crossing out causes whole. Doesn't matter. The points of discontinuity, okay? So this one has a vertical asymptote. Where does it have a vertical asymptote at? 3. Because of this right here. We set it, yep, set it equal to 0 and solve it out. The question I have for you, is it removable or non-removable? Why is it non-removable? Because I can't cross it out. So here's your question. Not that one. Let me drop down. I went the wrong way. Here you go. It's actually 21. We have 2 more before we get to 21. So not continuous at x equals 3. So there's A and D, and you told me it was non-removable. So your answer would be A. Again, why is it non-removable? We didn't cross it out. We didn't cross it. Holes are removable.
Can you go back up to 18 just so I can see it?
Uh-huh.
Yeah, I can see it.
All right, 19. Find any values, if any, at which the function is not continuous, which of the discontinuities are immovable. How do we have discontinuities? Poles or asymptotes. So I have to have what to start with? A what? A fraction, right? Do I have a fraction? This is continuous everywhere. Don't make it harder than what it is. Okay. Again, to have a whole or a vertical asymptote, I have to have a fraction. Is everybody good? Yep. This would be a question like this would be what you would get on your like free response. These questions. So part A might be find the discontinuities. Part B would be are they removable or non-removable? Something simple. Find the limit. All right. 20. Find the x values, if any, at which the function is not continuous, which of the discontinuities are removable. Where is it going to have discontinuities at? How do you know it's negative and positive 10? The bottom factors, right? You don't have to do the work, guys. You don't have to do the work. X squared minus 100 factors into x plus 10, x minus 10. Are they removable? No, because I can't mark them out. So my discontinuities are at 10 and negative 10, and they are not removable. So your answer would be D. All right, we will come back to 22. We did 21 already. I skipped and messed up. We'll come back to 22. There's nothing hard about this, okay?
Would the following students please report to the conference area? Mackenzie Walter, Kinley Simerson, Sophie Mueller, Amaya Wyatt, Presley Keeler, Tegan Kelly, Olivia Cream, Sailor Allen, Allie Smith, Sarah Cook, Caitlin Runnage, Jenna Jenkins, Sydney Lennox, Nora Hewitt, Allie Brown,
Bible.
Claire McDade, Kat Kibley,
She won't go there.
Lauren Crandall,
Well, she might.
Corinne Terry,
That's the whole JV and.
and Alana York. Please report to the conference area.
She just.
Doesn't matter. Doesn't matter. It doesn't matter. All right, guys, listen. Find the value of C guaranteed by the intermediate value theorem. Remember, that was where we were bisecting, cut in half. This is an easy question. It just sounds like it's really hard. So if we look at this, here's your function. Here's your values that they give you, and f of c equals 6. This is the same thing as y equals 6. So make sure you know how to do this problem. It's not a hard problem. It's a hard problem. All that's telling you to do is set that function equal to 6. How would I solve this? All right, that's going to be pointless. What? The only reason we would factor the top is if we could get something to cancel out, but we can't. So we're going to end up multiplying it back out. So I didn't mean that to be ugly. It's just you would have to multiply it back out anyway. So that would be a pointless move. How about this? Does that make it a little bit easier? What do you do? I didn't hear you. I can't hear you. I think you got a little bit quieter because you were worried about being wrong. All right, so we're going to cross multiply. Distribute your 6. And because I have x squared and x, I'm going to need to factor. So I need to get it equal to 0. Leave that x squared alone because it's already positive. I'm going to move my 6x and my 18. Which gives me x squared minus 11x plus 18. What are your factors of 18 that add to negative 11? What are your 2 answers? So everybody's got this, right? 9 and 2. So when I go back, the problem is I have two of those values. I have 9 and 2 on there. How do I know which one is right? You don't guess, it tells you how. What's 9 over 2? 4.5 to 18 is the value range that you're looking for. Which one of those fits in the value? 9. There, I got it. So that's why they give you that. So all I wanted to know is what 0 was between 9 halves and 18. Everybody good? Again, we'll come back to 22. It's not hard. I'm trying to get the easy ones first. So x to the 10th over x squared minus 9 as it approaches infinity or negative infinity as it approaches negative 3 from the left and from the right. So you're just going to fill in this chart. And when you fill it in, you'll see those values. So here are your values for the, you guys know how to fill in your chart, right? Okay, I told you there's like 2 on there. I think this is the second one and that's it. So negative 3.5 gives you 84878. 84878. Listen carefully. I'm just going across the top. So as we approach negative 3 from the left, that's the top. 134,365. 1.02 e to the 6. That means times 10 to the 6. Move it 10 steps. Where's it going to? The bottom value. Pay attention. I'm filling in the chart for you. Don't get mad at me. Don't get mad at me. Listen, you don't have to write it down. You don't have to write it down. Listen to the values. So I'm just going straight across that top chart. This is from the left. Listen to your values. 84,878. 134,365. 1.02 E6. E6 means times 10 to the 6. Where is it going? Positive infinity. So from the left, look down your thing. 3 to the left, negative 3 to the left. We want to go to what you just said. So it's either B or C, right? Everybody see that? The bottom chart. The bottom chart. Negative 9.8 e to the 6. Negative 9.5 e5. Negative 71,306. Negative 3468. The key in there is negative infinity. So your answer would be B. Now, when you look at this chart, your values as you read them left to right are going to look like they're going up. That's not what we're doing. We're approaching from the right. So you have to read them this way. I literally just said that. Listen, the top chart, you're reading from the left. So we're literally reading left to right. Your values will get extremely large as you go through. And they'll be positive. That'd be positive infinity. On the bottom, you have to read it this way because you're going from the left. Those will get extremely small and they will be negative.
I just have to think about this one would be negative infinity, this one.
Yes. All right. 25, vertical asymptotes. How do we find those? The ones that don't cross out, the denominator equal to 0, but we got to make sure it doesn't cross out first. I'm going to write this function down. You guys will be able to see it. So here's your function, x squared minus 4 and x squared plus 3x plus 2. What are your factors of x squared minus 4? On the bottom, factors of 2 to add to 3. These cancel out, they become whole, so they are not vertical asymptotes. So what is your only vertical asymptote? -1. So make sure you cancel it if you can. While we're working on this, Here's your next function. Haley, these are the ones that you like. We want to find all the vertical asymptotes of this function. You need to recognize that the top is perfect cubes. Perfect cubes. So x and 2 are your cube roots. So your first factor is x plus 2. Your second factor, square the first, change the sign, multiply them together, square the last. What happens? What are my vertical asymptotes? I don't have any. And that's the exact answer. So watch it. If you can factor, go ahead and factor. We will come back to, there was 26, so no vertical asymptotes. Please make sure you factor if at all possible. We'll come back to 27, 28. I'm going to go ahead and write this function down because this actually has work with it. Because if we plug in 0, it's going to give us 1 over 0, right? It's going to be like that indeterminate form. We can't divide by 0. You can graph this because we're going from the left, 0 to the left. I'll put it in my calculator and show you x squared minus this is what we have. We want to know the limit as 0 approaches from the left. So that's this side. So where does it go? Okay, let's go back to our answers. It actually is positive infinity. Positive infinity.
It just stopped. You should have. Why is it?
Where does it go to? Let's go to our values. What values could I put in? 0 from the left.
Negative 0.99.
Negative 0.99. Great. Are you leaving?
Debbie, closing her bottle thing.
No.
Hey, she gonna break
Yeah, I was right for that.
Nice. Guys, what's happening? Why is it doing that? I'll show you something different. Hold on, I'm gonna show you a different graph. Well, it's actually the same. There's nothing any different. What happens at 0? What is it? What does vertical asymptote mean? Say it one more time. Yeah. Have you ever seen it just stop at a vertical asymptote, or does it curve and keep going? So what's happening on this graph? Y'all understand what I'm saying? Yes. Yes. So let me see if that ain't gonna do it. Hold on. 20 years later. All right, this is a regular screen. Ignore it for a minute. Did it really stop? You guys see that? So what happens is it gets so close to that y-axis that it kind of disappears on this graph. So your calculator is incapable of graphing it that close and distinguishing between the two. Does that make sense? So it just kind of stops it. So on this one, just think about it. If it's a vertical asymptote, it goes all the way to infinity. It never touches it. I just zoomed in. Okay, hold on. This is regular screen. It's going to take 20 minutes to graph. Hold on, I'll show you. So when you go to zoom and in, so zoom, when it stops graphing, and I go to in, it always puts your dot at the origin. I just moved it up so I could see what happened right there. That's the point that I wanted to look at. And then when I hit enter, that's where it zooms in. All right, so your next one. What do you need to remember about this? Yeah, what is cosecant? It's the opposite of sine. Don't use that. Don't use that. Here you go. Here you go. So I wrote it down. We're going to do alpha y equals, and instead of cosecant, it's going to be 1 over sine. And then I have pi x over 2. So I did another alpha y equals in the bottom. Everybody okay with that? Bailey, are you okay with putting it in like this? All right. When I graph it, sorry, it's still zoomed in. Dang it, Higley. You're okay. You're okay. I want you to ask questions. All right, so here's your actual graph. But we're only looking at the limit as it approaches 2 from the left. 2 from the left. So 2 is right here. This is the left. Where is it going? I'm sorry, this is the right. This is the left. Where is it going? Positive infinity. So positive infinity.
Where can I find these little boxes that stuff in them?
What do you think?
If I saw, I would not know that it was coming.
We've been over this before.
I don't know.
Not but no. You have sine, cosine, and tangent. And I always remember them in this order because of SOHCAHTOA. Okay. When you do your other ones, Cotan has tangent in it, you know that it's the opposite of that one. What are your other two functions that you have? Cosecant and secant, right? Put them in alphabetical order if you're listing them this way. Cosecant, secant.
So then all of them are like one over. Oh.
That's,
That's how I.
That's how I remember it.
but the H.
But it's always got to go SOHCAHTOA. If you don't get that right, then it won't go in alphabetical order.
So if I see tan, if I see tan, whatever.
Whatever tan.
Whatever.
Mhm.
Okay.
All right.
I wouldn't be the only one.
We'll come back to 27. We may do 27 before the test one. I don't think it'll be out tomorrow. I think it will be okay. If not, I'll make you a video and send it through your email. I'll let y'all know. So check your email later. I gotta make sure my mama will watch my baby. All right, so find the constant A such that the function is continuous on the entire real line. So I don't want any gaps, like jumps. Does everybody understand that? So this is exactly how I did it. You can write these down. Hold on. Yep. All right, I'm going to show you. Hold on, it's going to be up here. So this is your function. This is exactly how I did it. Alpha y equals -4 times sine x. Oh, wait, I got to do it different. Alpha y equals -4. Alpha y equals, nope, that's not what I want either. There it goes. Sine x over x. And then remember, you can do your x is less than 0. And then I literally plugged in those values. So, so on the first one, 1 plus 7x, alpha y equals 1 plus 7x when x is greater than or equal to, how about you do it right? X is greater than or equal to 0. All right, so the only thing I'm going to do is I'm going to keep changing that number in the top, okay? So when I graph it, I want this to be continuous. It's going to take a minute. Is that a continuous function? Why? It's got to jump. Okay, so now I'm going to change that A, instead of being 1, I'm going to change it to -7. But I'm gonna make it a little bit easier in just a second, okay? So when I plugged in 1, it started at 1. When I plugged in -7, watch where it starts. Oh, -7 down there. So where should I start it at?
-4.
-4. So let's try -4. Let's use some deductive reasoning. -4 plus x. We're going to graph it. Does that make it continuous? That's literally all you do.
You're gonna have me all worked up about this.
I told you it was not hard. It just, I didn't hear you. Where do you put what? At the A. Because that's what we're looking for, is that A value. Is everybody okay? What time y'all get out of here? Okay. We have one more. All right, we have this 27. It says find the vertical asymptotes of any of the function. So this one, Typically, your tangents you can find when you graph this, it looks absolutely ridiculous. So if I graph tangent 15x, it's going to take forever. This is what it looks like. Right? So there's a lot of vertical asymptotes. Everybody understand that? Yes? All right. So you're going to take that 15x and you want to find where pi over 2 is going to give it to you. I'm telling you it's b. I'm telling you that it's going to be b. How do you get the 30? You multiply this 15 over, or you divide by 15. So you know it's got to be over 30. That's the only one that's over 30. Yeah. And why did I use pi over 2? Because typically pi over 2 is where tangent has vertical asymptotes. This just happened to be 15.